Hello everyone, this is Tobias Mhlongo, and I'm back again. And in today's video, we'll be looking at the grade 12 physical science final exam for chemistry paper 2, November 2023. And we're focusing in question 1.1 to 1.3 for organic chemistry and question 2, which is nomenclature. So let's get straight to it. In question 1, which is your multiple choice question, and 1.1 said which one of the following represents a straight chain saturated hydrocarbon, and we know that a straight chain saturated hydrocarbon would be simply an alkane or a haloalkane, but then since from this option here there is no halogen present, so we're going to conclude that it's just an alkane. And for an alkane, you know that the general formula is what? It's C, say CnH2n. So let's go through the first option, option A. If it's a CnH2n plus 2 for an alkane, it must be C5, which is C5, 5 times 2 is 10, 10 plus 2 is 12. So therefore A is totally incorrect. And the same with B. C5, 5 times 2 and plus 2, that will be what? 12. Still not correct. Then if it's a C6, H 2 times 6 is 12 plus 2 is 14. It gives C incorrect. And therefore the correct answer would be D. And then when we get to 1.2, which one of the following is a secondary alcohol? First, you need to know what is a secondary alcohol. Secondary alcohol is an alcohol whereby the carbon containing the hydroxyl group is attached to two other carbons. So you wouldn't know this from this condensed structure, so you'd have to draw each one of them from A, B, C, and D. So let's try and draw each one of them. Let me see if I can erase it so I can draw here. Right, I'm going to be drawing almost everywhere in this with maybe a red color for the first structure. So the first structure is just a CH3. So it's C with CH3, and CH3, and CH3, OH. That is definitely not a secondary alcohol, because if we look at 1, 2, 3 with the carbon bonded, so that should be tertiary. Then we look at number B. Number B is a CH3, CH3 attached to a CH2 and a CH2 and a CH2 that is attached to a C H2 and OH. That also doesn't look like an alcohol. Just erase this. That would be what? OH here on the third CH2. So it's OH like that. this carbon is attached to two hydrogens and only one carbon here, the one containing the OH. So definitely that will not be a secondary alcohol. Right. The third one, let's do it here. CH3, CH3. I'm not going to attach the hydrogens, and a CH2, and then CHO means this is a what? This is a aldehyde. So if you see HO, you know it's an aldehyde, but OH, it's hydroxyl. So this is definitely not the answer, and your correct answer would be D, because this is not it, and this is not it, and this is not it, and therefore by default it's D. If we have to draw the structure to show that it's D, let's quickly draw D. D would be made of a CH3, CH2, and then CH with OH, and a CH3. Let's put down the H's to show that this is a secondary alcohol. Now, carbon bonded to the hydroxyl must be bonded to two other carbons. That makes it secondary, and that is how we got to say this is the correct one. And then question 1.3 takes us to the definition of what a hydrolysis reaction is. Hydrolysis reaction is a reaction of a compound with water. Now, there are two reactions with water here, which makes B and D to be already out. Now, we're already looking at what? Excuse me. A and C. Now, hydrolysis reaction in organic chemistry would be a reaction of a haloalkane to produce an alcohol. Option C is out because this is an alkene, an addition reaction that produces an alcohol. And therefore, option A is the correct answer because it's a haloalkane substitution of the bromine to a hydroxyl group. And let's look at what question 2 was like. Now, question 2 had some sort of an error. I don't know, maybe it's a printing error or what, whereby compound E. Let me take this smallest, the tiniest pen here. Compound E, I think here it's supposed to be a 3. Edit here. It's supposed to be a 3 here. CH3. Well, let me just erase first and right, this is a CH3. Let's do the right color. Okay, not working out. But this was supposed to be a CH3. Yeah, you can see the CH3 there now. Because carbon has to be bonded to 4 bonds. Now, first things first, 2.1, before we can even understand what's going on in this table whereby we have IUPAC name, IUPAC name, IUPAC name, IUPAC name from A to D, and then structures from E to H, which is 8 compounds. 2.1 wanted a definition of an organic compound. I don't like writing down definitions, but I'll just say it out. An organic compound is a compound that contains carbon atoms, and that was your how many marks? 1 mark. Then for compound E, which is the structure that we said had a, I don't know what to call it, had an error or a misprint. If you put the CH3, then this leaves us with labeling um, our carbon 1, 2, 3, and carbon 4, or carbon 4 here, meaning this and this would be our substituent, and our functional group would be here, which is the double bond, making this compound first things first and alkene. Now, what's the name of this alkene? Because we're looking for the IUPAC name. So, first, 4 carbons means what? Means but. Where is this double bond in carbon number 1? And we said that this is an alkene. The substituents that we identified are what? Since we are going with the yellow, we now ignore the red one because our parent chain is what? Is 1, 2, 3, 4 in yellow. And therefore, this means we have substituents in carbon number 2 and carbon number 3. What are those substituents? Those are 2 methyls. 2 means dimethyl, where in the 2, 3 position. So this is 2, 3 dimethyl but 1E. Then for H, this is simple. The homologous series here is a ketone, and this ketone can be named with 2 names. We can either call it butanone or 2-butanone. I think those 2 would be accepted because this is the first compound for a ketone, because you need to, well, either call it butanone or 2-butanone. The structure is just butanone, but I think the most correct one is 2-butanone or but. 2O for position of where the ketone is occurring. But whether you flip the structure left or right, um, in a racemic, or I would call it mirror image, still in position 2. Then they want the structural formula of compound B. Now with this one, I think we have to get a bigger screen. Let's take this one out. Done. What's the name of compound B? Or compound B is this CH3 with 3 CH2s and a C double bond with an O and a CH3. Okay. So I might need to take this one down a little bit. So it's a CH3, CH3, and 3 CH2s. And then it's a C double bond. Or it's a COO, which means it could be a C double bond O and an O with a CH3. And that would be your structural formula of compound B. Then compound C is a 4-ethyl 3,3 difluorohexane. Now, if we check out the structure here, take it in green. So it's a haloalkane. Haloalkane with a what? Hexane. So it's 1, 2, 3, 4, 5, 6. The hexane. Now, already positions are given. At position 3.3, if you're starting from left to right, this is 1, 2, and 3. 3 has what? 2 fluorides. Then position 4, if you're starting from left to right, has a what? Has an ethyl group. So it's C CH3, CH3. Well, CH2, CH3. Then we put in these H's. Which means it's a 1, 2, 3, 3, 4, 5, and 6. So 3, or 4 ethyl, it's 4 ethyl, then 3, 3 difluorohexane. Okay. Then 2.3.3. General formula for which compound E belongs to. Now, remember, compound E was that structure which we had to edit with a CH3. We already saw the double bond, so it means it's a alkene. It's an alkene, and you know alkenes have what? General formula CnH2n. That is our 2.3.3. And then 2.3.4, the structural formula of the functional group of compound F. Now, compound F, if we may go back to this question here, compound F. Compound F is having this here. Right. Compound F has a carbonyl or formyl group that is attached to two carbons here, which makes it a ketone. And the structural formula of a ketone is, go back, so a ketone that will be a C double bond attached to C and C. That's the structural formula of the functional group. And 2.3.5 had the IUPAC name needed to produce compound B. So let's go back to the structure of compound B that we drew here. Compound B is this one here, and I always advise my learners to follow this. We get this O8 part from the carboxylic acid, and we get this alkyl part, from the alcohol. So which means this is our alcohol. So what was this? From the alcohol, only hydrogen is removed, and then from the carboxylic acid, the hydroxyl is removed in this ester formation. So our alcohol in 2.3.5 would be what? I don't know. If you want its structure, there you go. Right. Then 2.4.1. They ask us to write down the letters of the compound that is a functional isomer of compound G. Now, what is compound G? Go back to the question. Compound G is here as a carboxyl group, so it's a carboxylic acid, and we know, or we should know, that a carboxylic acid's functional isomer is an ester. So to get, we only having one ester from this question, which is the structure that we just drew, compound B. So to confirm that these two are isomers, we need to count the number of carbons and get the molecular formula. Right, now we have carbon 1, 2, 3, 4, 5, 6. So it's a C6, C6, H 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. C6, H12, O2. Right. That is our compound G. No, not G. Compound B. So If B is a ester, and let's say C6H12O2, and G is also an ester. And you can go and count it. Number of carbons, number of hydrogens. It's carbon 1, 2, 3, 4, 5, 6, and hydrogens 3, 6, 9, 10, 11, 12, and oxygens 2. So it's a C6H12, C6H12O2. So yes, they have different functional groups here. So therefore they are functional isomers, and therefore the answer for 2.4.1 functional isomer of G would be what? Letter number B. And the other one says the ones that are chain isomers. Now you'd have to understand what is a chain isomer. And a chain isomer is defined as per exam guideline as an isomer or a compound with the same molecular formula but different types of chain. Now we have different chain isomers, but in this case we have to look at them thoroughly. If we look at the carboxylic acid, we have about how many carboxylic acid? We have A, D, and G. And in G, you can definitely see that we have what? 6 carbons. And in D, we already have what? 6. Because it's hexanoic acid. So definitely it would be C6H12 with O2. So these two are isomers of each other. But this one is not a long chain. So it's a branched erase here. Okay, can you erase that? It's a branched. Where is it branched? It's branched here. This branched. So this would be the long chain, and therefore it's branched here. That's the string. So that makes it its chain isomer. So therefore G and D are chain isomers of each other. And that G and D would be the answer. And that puts us to the end of our video for today. Thank you guys. Please continue watching our videos and subscribe and like.